Hello everyone, welcome back to my channel. Myself Likita Argara. Today I'm here to explain about merge sort. Contents: Introduction, example, time complexity, applications of merge sort, advantages of merge sort, and drawbacks of merge sort. Introduction: Merge sort is defined as a sorting algorithm that works by dividing an array into smaller subarrays, sorting each subarray and then merging the sorted subarrays back together to form the final sorted array. In simple terms, we can say that the process of merge sort is to divide the array into two halves, sort each half, and then merge the sorted halves back together. This process is repeated until the entire array is sorted. Let's see the example. Let's consider an array that is 38, 27, 43, and 10. Initially, divide the array into two equal halves. That is, splitting the array into two equal halves. That is, here we are going to split these four numbers into two equal halves. That is 38, 27 one side, and another side there is 43 and 10. Next step. These subarrays are further divided into two halves. Now they become array of unit length that can no longer be divided, and array of unit length are always sorted. Okay, here 37 and 27, 38 and 27 is splitted again. That is 38 and 27 separately, and which follows for 43 and 10 also. Step 3. These sorted subarrays are merged together and we get bigger sorted subarrays. That is 38 and 27, which were in unit length, then sorted and kept as a merged one. Here, first there was 38 and 27. Now, after sorting it, we get it as 27 and 38. And for 43 and 10, after sorting, we get the 10 first and 43 next. Step 4. This merging process is continued until the sorted array is built from the smaller subarrays. And next, here, the 27 and 38 is sorted and 10 and 43 is sorted. And for next, we'll merge both together. That is, here 10 comes the first, which is smallest, and then 27, and next 38 and 43. And here, the last step, this is what the merged one. Now let's see about time complexity. Best case complexity. It occurs when there is no sorting required. That is, the array is already sorted. The best case time complexity of merge sort is n log n. Average case complexity. It occurs when the array elements are in jumbled order, that is not properly ascending or not properly descending. The average case time complexity of merge sort is n log n. Worst case complexity. It occurs when the array elements are required to be sorted in reverse order. That means, suppose you have to sort the array elements in ascending order, but its elements are in decreasing order. The worst case time complexity of merge sort is n log n. In this merge sort, the best case complexity, average case complexity, and worst case complexity are all equal. Applications of merge sort. Sorting large data sets. Merge sort is particularly well suited for sorting large database sets due to its graduated worst case time complexity of n log n. External sorting. Merge sort is commonly used in external sorting where the data to be sorted is too large to fit into the memory. Custom sorting. Merge sort can be adapted to handle different input distribution such as partially sorted, nearly sorted, or completely unsorted data. Advantages of merge sort. Stability. Merge sort is a stable sorting algorithm, which means it maintains the relative order of equal elements in the input array. guaranteed worst case performance. Merge sort has a worst case time complexity of n log n, which means it performs well even on large data sets. Parallelizable. Merge sort is a naturally parallelizable algorithm, which means it can be easily parallelized to take advantage of multiple processors or threads. Drawbacks of merge sort are space complexity. Merge sort requires additional memory to store the merged subarrays during the sorting process. Not in place. Merge sort is not an in place sorting algorithm, which means it requires additional memory to store and sorted the data. This can be disadvantage in applications where memory usage is a concern. Not always optimal for small data sets. For small data sets, merge sort has higher time complexity than some other sorting algorithms, such as insertion sort. This can result in slower performance for very small data sets. And here is the example. Here there are 8 elements and they are 14, 31, 25, 4, 74, 32, 66, and 7. And these 8 are going to divide into two halves, that is 4 on the each side. Then 14, 31, 25, 4 is one side and 74, 32, 66 and 7 is another side. And for the first divided one, there are 4 elements and which it subdivides into 2, 2 each. And then comes 14, 31 on one side and 25, 4 on another side. And same follows for the another set of 4 operations. That is 74, 32 one side and 66 and 7 another side. And this both the terms are going to divide into the units. This is nothing but 14 and 31 are divided so that this is the last, so that it can't be divided, and so on follows for everything. And then 14 and 31 is already sorted, so which comes first? 14 comes first and 31. And in 25 and 4, 4 is the smallest and which comes first and 25 comes next. And 74 and 32 also. 32 comes first and 74 comes next. And same follows for 66 and 7. 7 comes first and 66 comes next. And here then it's going to divide, merge from 2 and 2 for 4. In this, 14, 31, 4, 25, the smallest is 4. Then comes 14. Then comes 25 and 31. And here also for 32, 74, 7, 66, the first one will be 7. And next comes 32, next comes 66 and 74. And this subdivided merge one will be totally merged and form a, and after sorting this, the last one will be of 4, 7, 14, 25, 31, 32, 66 and 74, which is sorted in ascending order. And this finishes the merge sort. Isn't it easy, guys? Thank you for watching my video. Please do like, share and subscribe.